Sorry about that, guys. I went to move an email up and swipe up and it stopped my camera from going. Anyway, here's the next example. This one says, simplify 1 plus sine u divided by sine u plus cotangent u minus cosine u over cosine u by rewriting the expression as a single ratio. So basically, you have one fraction plus another fraction. They want you to simplify that. And they wanted you to simplify it down to the smallest possible trig function you can get it to. All right? Well, if I'm going to simplify this, this is basically, I'm going to have to, a single ratio, they want you to make this one fraction. They want you to add these two fractions together. Well, in order to add fractions, you have to have a common denominator. So we're going to have to get a common denominator. All right? So what is the common denominator between sine u and cosine u? What does this denominator need a factor of to look like that one? It needs a factor of cosine u. So we're going to have to times the top and bottom of this fraction by cosine u. Okay? And then come over here. What does this denominator need a factor of to look like this one? It needs a factor of sine u. So I'm going to have to times top and bottom by sine u. Okay. Now, in this example, it wasn't necessary to multiply these actually together. Here, though, because when you add fractions, you do actually end up adding your numerators, you are going to want to distribute and multiply it, okay? Because I can't add my tops if I have parentheses everywhere. All right, so let's distribute. So if I multiply the top of this fraction by cosine u times 1 is cosine u, right? Okay, cosine u times positive sine u is going to be positive cosine u sine u. And then it's going to be over, now my denominator will say cosine u times sine u. Okay, now we come over here, plus. Now I'm going to multiply top and bottom by sine u. So sine u times cotangent u is going to be cotangent u sine u. Sine u times negative cosine u is going to be negative cosine u sine u. And again, the order in which you write these won't matter. If you did sine u cotangent u or sine u cosine u, it won't matter. All over, again, my common denominator is going to be cosine u times sine u. Okay, now I can add my numerators and keep my denominator the same. So if you notice, you're going to have cosine u plus no other cosine u, so there's no like terms, if you will. All right, and then you're going to have a positive cosine u sine u plus a negative cosine u sine u. They're going to cancel out, okay? And then you're going to have nothing over here that you can add with this cotangent u sine u, so he will stay a positive cotangent u sine u all over a common denominator of cosine u sine u. Okay. Now again, don't get crazy and think they cancel because they can't because of that addition. You cannot cancel them. So in this case, what you're going to want to do next is, well, I don't know, things might start popping out to you as you work with these, but if you think about this term, right, like they're not like terms, so how would I add them together any more than they already are? Well, again, here might become a good time to try to get everything in terms of sines and cosines. Like, what's cotangent u if you rewrote it in terms of sines and cosines, right? So now it would be cosine u, right, plus that's going to be cosine u over sine u, times sine u, all over a common denominator of cosine u sine u. Okay, well guys, look here. What's going to happen to this sine u and that sine u? They cancel, and you're going to be left with cosine u plus cosine u, which is going to be 2 cosine u, over cosine u sine u. Well, now everything's attached by multiplication. There's no adding and subtracting standing in our way from canceling anything. A cosine u and a cosine u are going to cancel. And now you're left with 2 over sine u. Now, I feel like years ago, they would have accepted this. As long as you got this down to a simplified version and that your final answer was in terms of sines and cosines, you'd be done. But you can make this a little bit simpler and not have your answer written as a fraction if you keep going. So guys, think about it. If this is basically sine u in the denominator, then when you reciprocate it, it actually becomes his reciprocal, which is cosecant. So this is actually, think of this as, 1 over sine u that you're pulling out. It's 2 times 1 over sine u is what this is equal to. Well, who's 1 over sine u? Cosecant u. So really it becomes 2 times the cosecant of u. So now this whole expression simplifies all the way down to just 2 times cosecant u. And that's your simplified trigonometric identity, or trig expression, I should say. It's your simplified trig expression. Okay? All right, perfect. One more for today. All right, look at this one. Simplify sine squared v minus 1 divided by tan v sine v minus tan v by factoring. So they're telling you that you should be able to use methods of factoring to simplify this trigonometric expression. Okay, well, I don't want you guys to fall into traps. I don't want you to be like, oh, wait, I know that's a Pythagorean identity, right? That's cosine squared u. Remember, this is not cosine squared v. 1 minus sine squared v would have been an identity, right? Like, where is it? Here. Cosine squared theta is equal to 1 minus sine squared theta. This is sine squared v minus 1. So that's not an identity, actually, okay? So be careful like that. But what I want you guys to realize is this is something squared minus a perfect square. One's a perfect square. So technically, guys, this right here is the difference of 2 perfect squares. Think of this as a squared minus b squared, right? So he would factor to a plus b, a minus b. So this is the difference of 2 squares. So guess what? He's going to factor to sine v plus 1 and sine v minus 1. I'm telling you right now, if you FOIL them out, they will equal sine squared v minus 1. So the difference of 2 squares always factor to the same 2 factors, 1 positive and 1 negative. All right, divided by, now when you go to the bottom, you don't have any squared functions like that you could think of factoring the difference of 2 squares, but what you should be thinking is GCF. What does a tan v sine v have in common with a tan v? They have a tan v in common. So take tan v out and show what's left. Factor out that GCF. I'd be left with sine v and then minus 1. Well, guess what? What happens to sine v minus 1 and sine v minus 1? They're going to cancel. So now you're left with sine v plus 1 all over tan v. And you're done. You are now in a simplified version of that expression. Now, sometimes you might think, oh, should I do sine v over cosine v? You could try it, but I don't believe in this case it's going to get you to anything that is a simpler expression than this. So there might not be any point to moving on. All right? So that is your final answer. All right, so again, a lot of this is just manipulating. What can you rewrite? What can you take out? And what can you put in? Okay? All right, I'm going to give you a few homework questions on this day's notes, and then I'm going to do a few more examples on your day 2 notes. And then, guys, like I said, that's it. We're done. This is the last section we're going to get to. You have done so great. Hang in. 1 more days of notes.